Welcome to my channel. Let's do some more Leetcode today. I'm Leo. So today's question is alien dictionary. So we were given a new alien language that uses the English alphabet. However, the order of the letters is unknown to you. So it's not just like A, B, C, D. You're given a list of strings words from the alien languages dictionary. Now it is claimed that the string and words is sorted lexicographically by the rules of the new language. So that means, let's take a look at the example. So here, WRT and WRF. If this is true, that means T must go before F, because the lexicographically smaller will be at the front. Okay. So if this claim is incorrect, and given the arrangement, the string words cannot respond to any order of letters, return empty string. So an example is here, ZXZ. In this case, Z must go before X, and X must go before Z. But this is not logically correct, because we have a cycle here. Okay. Therefore, we can set an empty string as an output. Otherwise, return the string of the unique letters in only new alien language sorted in lexicographically increasing order by the new language's rules. If there are multiple solutions, return any of them. Okay. Let's take a look at the example. So, as I just said, we compared the first two. So T must before F. We can draw a line from T to F. And then for the second one, W and E, they're different from the first character. So W must go before E. Therefore, we can draw a line here. And for the third comparison, E is the same, and R must go before T. So we can draw a line from R to T. Then, the last one, ER, E must go before R. Okay? So now we can draw a graph like this. So W goes before E, and E goes before R, and T goes before F. Then R goes before T. Then the last one, yeah. Now we can have a solution. W goes before E, E goes before R goes before T, T goes before F. So our final ordering would be W, E, R, T, F. Is that right? Okay, sounds good. Although there are many corner cases to check, for example, if this one and this one, WRT goes before WR instead of WRF. In this case, they have something in common, and the first word starts with the second word. So this cannot be a correct ordering. So we have to return a empty string. Okay? Yeah. All right. So let's do this. This looks like a typical topological problem. So we can put the first character without the in degree into our solution. Okay. So what do we need now? We need a mapping. We need a adjacency list for every character. Then we need a map that contains the in degree of each character. Okay. So the first thing is the map character, a list of characters that it points to. It's going to be a new hash map. Okay. The second thing, map. Each character will need a in degree. It's also going to be a new hash map. Okay. Now let's construct the graph. So for string words, for each string, for character, to character array, for each character adjacency list, it will put C and new array list. Okay. And for the in degree, we'll also put C, and it's going to be 0. Okay. Then, first we have the containers, then we have to populate it. So we traverse through all the words in the string array. For I equals to 0, I is less than words.length, -1, I plus plus. Why? Why do we do this instead of word.length? Because we have to compare not 1, but 2 of the elements in this string array. So naturally, we need the first word and the second word. So let's write it out. String word 1 is words I, and string word 2 is word I plus 1. Okay. First, let's do some sanity check. So if word 1.length is larger than word 2.length, and word 1 starts with word 2. That means word 1 is longer than word 2, and it starts with word 2. So this cannot be a correct ordering, so we return an empty string. Okay? If that's not the case, we can do our sorting. So when do we compare them? When for j equals to 0, j is less than the mean length of the 2 words. Okay, so word 1.length, word 2.length. Okay, yeah, for each of them, if they're different, like word 1 dot character at j doesn't equal to word 2 dot character at j. If they're different, we have to add a pointer here from the first one to the second one. So we put it into the adjacency list. Let's get word 1 dot character at j and add word 2 dot character at j. Okay. Then we have to get the in degree. So the in degree applies to the second word. So we have to put word 2 at character at j. Put what? Put the put plus 1 to the original count. Get word 2 dot character at j plus 1. Okay. Then we can break. We can get into the next loop. And we have to take a break here. Okay. Yeah, when the graph is constructed, we can do our topological sorting. So we need a queue to contain all the characters, and it's going to be a new linked list. And we're going to traverse through the in degree map. And we still need the characters. So the characters is the key of the map. So for character C, can we still use a C here? In degree dot key set. If in degree dot get C, the count equals 0. We're going to add it into the queue. Okay, then we can do our expansion. While queue isn't empty, we can pull the character out Then, we have to get a string builder here, or we can't compile, or we can't compose the final output. Okay, so the word with the 0 in degree is our first character, so sb.append c cur. Okay, and for the neighbors are character like cc adjacent to list dot get cur. For all the neighbors, we're gonna decrement the in degree, so we can put cc in degree dot get cc -1, and if in degree dot get cc equals 0, we can put it into the queue. Okay, yeah, our topological sorting is completed by now, so we can return string builder dot to string. Okay, but before that, there's one more thing to do. There is a problem, like if the dictionary was like z, they were all the same. We can also construct a valid ordering, which is only z here. But with our existing logic, we didn't handle this problem. We didn't handle this situation. So yeah, if they're different, we do something. But if they're not different, they're the same, we do nothing. In that case, we're not actually populating the list, so there's nothing. Okay, so what should we do? If string builder is less than the adjacent list dot size, if it's not the same, the size, okay, so if we have z, if it's different, we can return an empty string. Okay, let's see if it's correct. Okay, I think it passes. Let's submit it. All right. Okay, yeah, that's the thing we have here. Thank you all for watching. I'll see you in our next video.